I welcome you to our Certified DevOps Engineer Live Free Training Program. This is our roadmap, and according to it, we have very successfully completed day 1 to day 7, and we are going through with day 8 monitoring and visualization. And this is part 2 of day 8. Before we go ahead, I personally want to acknowledge and thank each and every one of you for your kind support and love. Thank you very much for that. These are our social media handles. Would love to stay in touch with you. So, what we will cover today, as you know, day 8 is divided in total 6 parts, which we already discussed in great detail in part 1. And in part 1, we have discussed all the fundamentals and key concepts like what is monitoring, types of monitoring, infrastructure, security, AI-based application, network, and so on and so forth. So all the fundamentals we had covered in part 1. If you'd like to refresh your concept, feel free. And today we are going to diving into the Prometheus, a powerful monitoring tool that used in modern infrastructure. So we will start with what is Prometheus, then we will break it down into the Prometheus architecture, explore its components, and take a deep dive into how it works. And we wrap up the session with the use cases and limitation, where to use Prometheus and what are its limitation, where you cannot use the Prometheus. Of course, it's a very great tool, very strong, very powerful tool, very modern tool, but like each and every tool has some limitations. So that we will see in this. So let's get started with first topic. What is Prometheus? So let's see, according to official documentation, Prometheus is a system monitoring and alerting system. Official document also says another definition where it mentions like this: Prometheus is an open source system monitoring and alerting toolkit. Here, if you see, it says system monitoring and alerting system. It doesn't say system monitoring alerting system, right? And similarly over here as well. So alerting is toolkit. We already discussed this in part 1. What is monitoring, what is alerting means, right, in very, very great details. And I knew this, that's why we had a dedicated part 1. Okay, so these are the two definition, but let's explore one more definition, which I would like to define Prometheus in this way. So Prometheus is an open source monitoring system and time series database designed for collecting and storing metrics, which follows pool based model where it scraps metrics from targets at regular interval. So you might be wondering, we have very simple one-line definition. So why are you being crazy and defining Prometheus in this way? It is like somebody has a drop a bomb on me, right? Not on me or not on you. So there is a simple reason behind it. Okay. So if you closely observe the way of defining the Prometheus in this way, here there are some keywords like time series database, right? Metrics, pool-based model, and it scraps, right? And targets and regular intervals. So when you explain, especially when you are giving an interview, okay, I mean, where your interviewer asks you what is Prometheus, and if you explain in this way, so it means you are taking a control of your own interview. How? You have already provided 1, 2, 3, 4, 5, 6 follow-up questions already to your interviewer. Okay. So for example, like you said, Prometheus is an open source monitoring system and time series database designed for collecting and storing metrics. Then if an interviewer say, okay, then now tell me what is time series database. So in this way, you have an opportunity to lead your own interview. Okay, rather than your interviewer is going to ask you a question, you are providing in advance question to your interviewer. Okay, so this is just a one reason. So for time being, make a note of all these terms which are really, really important, and we are going to use now onwards in rest of the all the parts this terminology very frequently. We will again refer this definition, we will again revisit this definition, and then you will be able to understand each and everything. So I'm gonna explain each and everything shortly. So this is about Prometheus. Okay, and before we go ahead, let's see some of the fun facts about the Prometheus. So Prometheus was originally developed at SoundCloud to handle their growing microservices architecture, and it was open sourced in 2012, and it is developed in Go language. Prometheus follows a pull-based monitoring. So pull-based monitoring is simply, it means Prometheus is going to the devices, the server, the application where or what we ask Prometheus to monitor. So Prometheus reach to those. I don't want to tell the technical term. We will come on that later, but consider the devices or in short, okay, the whatever thing we want to monitor via Prometheus. So Prometheus goes to all those things and get the monitoring data. So that is pool based model. Instead of the application sending data, monitoring data to Prometheus, Prometheus is going to collect the data. So unlike traditional monitoring tools, they rely on pushing the data. Prometheus pulls metrics from the target at specific intervals. So again, I use the term metrics. So we in part one, of course, I think more than 200 or something different kind of metrics I already mentioned about. Okay, but don't worry, I'm not forcing you okay to go ahead and work that. We are coming on that point. So simple pull based monitoring, it means Prometheus is going to get the data, and there are some advantage of this. We will discuss shortly on this, what are the advantage of this kind of monitoring. Okay, next we have alerting system. So Prometheus comes with alert manager, which helps manage alerts and notification based on predefined conditions. So you really do not need to configure any additional tool which do the alerting. So there is an inbuilt alerting already with the Prometheus which comes. We have to just enable that, set up that. Okay, we will see that in next part 3, when we install, okay, Prometheus. So we will see how we set up alert. So that will be okay. So but for now, it's a fun fact, Prometheus has an inbuilt alerting system. Next we have PromQL magic. Okay, so Prometheus has its own query language to retrieve data, okay, which allows user to slice and dice time series data efficiently. So see again, the term has come, time series data. So we are coming on that shortly. Hold on your thought, okay. So PromQL magic. So it's a PromQL. So Prometheus query language, which is really amazing, very easy. I don't know why people say it's a complicated, but I really didn't find it complicated. And I will make sure when we will go ahead and see these queries, you will realize I will break it down to very small level that you will be able to understand. So PromQL, it's a magic thing. We will see that later. And Prometheus is designed especially for dynamic environment where we have microservices. So nowadays we only everybody deploy their application whether in container or in Kubernetes environment, where application pods come and go, okay, and we cannot track all the times. So in that kind of dynamic environment, Prometheus was designed for that specifically. So when your service is automatically scale up and scale back down, okay, so those metrics for those is also easily monitor using the Prometheus. So don't worry, we will go ahead and see everything in more detail. Last but not least, so Cloud Native Fabric. So Prometheus is the second project to join, as well as the graduated within the Cloud Native Computing Foundation after the Kubernetes. And Prometheus, as I said, Prometheus was open source in 2012, and it joined later to the Cloud Native Computing Foundation in 2016, and in 2018, it became one of the CNCF's most widely adoptable monitoring solution. So when we do the installation, you will realize this is one of the amazing tools, especially for where you want to monitor your workload, which is dynamic in nature. But it is not, but later on, or I would say it is not only the thing, we can also see what other things we can monitor. Okay. And if you want to read more about this fun facts, go ahead and check out the Prometheus official documentation, prometheus.io. Okay. That's a website, and read about that more. There are so many plenty, I'm sure. So this is about the Prometheus, and it's a fun fact. Let's go ahead and see our next topic, the architecture and its component. So one of the very important, crucial, or I would say the heart of the overall ecosystem is the Prometheus server, or the server simply, which is responsible. So this is one of the component which is responsible for collecting a data, and it collects data from the Kubernetes cluster or container or your application or cloud environment or bare metal machine, or maybe your application is running on any of this. So Prometheus is capable enough to get and collect the data from all of this. Okay, and collectively all these things are called destinations or destination or endpoints. Okay, so we have first component, it's a Prometheus server itself, which is responsible for collecting a data from the endpoints. So now I'm not gonna say Kubernetes this whenever I say endpoints or destination, simply understand okay what we are referring about. So it collects data, so it is responsible for collecting a monitoring data. Okay, and based on the predefined condition, those condition doesn't match, then it sends an alert, and it sends alert via alert manager. So that is the another component in the architecture. So it's very simple. Okay, we have Prometheus server, which is responsible for collecting data and sends alert via the alert manager. So the process of collecting data, which is referred as a scrap matrix or pulling the matrix. So as I said before, Prometheus is based on, or it works on the pull based model. So Prometheus goes to all of endpoints or destination and collects the data. So the process of collecting this data is called in Prometheus world as a scrapping matrix or pulling matrix. So there are two terms again I mentioned over here. One is scrap and another one is pull. So there is a slightly difference. We will also come on that, and I will explain you what is the difference in scrapping as well as the pulling. Okay, but for now it's enough. Simply we could say scrapping the matrix or pulling the matrix interchangeably. All good, no worries at all. Then this destination or endpoints in Prometheus world, these are called as a target. So now we can say Prometheus scrap the matrix on regular interval from targets, and if something went wrong, it sends alert. And this thing sending alert, it's called pushing alert. So Prometheus doesn't send alert directly. Okay, it's alert, or it push the alerts to alert manager, and then alert manager takes the necessary action whatever we have configured over here. So alert manager perform the action accordingly. So for example, if any alert is there, you have configured to send a chat notification, so it will alert. So alert manager send alert in your chat. If you want, it sends an email, it can also send email to you. Okay, we are coming on deep dive part where we will see how exactly alert manager works. Okay, and when we again refer back this definition where it says Prometheus is a system monitoring. So Prometheus is a system monitoring and alerting system. So in short, Prometheus has three main component. Okay, for now, or as a basic level, or at a high level, Prometheus server itself, which has to contact, okay, or which has to scrap the matrix from the targets at regular interval. Okay, so when we install, I will show you how regular interval means, and we can also do the customization according to our need. And when it finds something, or it found something which is abnormal, it immediately push alert to alert manager, and alert manager perform its job. Simple. Okay, so this is about Prometheus architecture and component. Okay, but how do they work actually? So that is our next topic. Let's explore. So this is the diagram we already talked, Prometheus architecture and component. Let's break them down in more detail. So first, of course, we start with Prometheus server. So in Prometheus team, it is not on alone. So very first candidate in Prometheus team is a retrieval. Retrieval scraps matrix from a configured target at regular interval. So retrieval is I would say the component, or it's a worker process, or it's a first candidate in Prometheus server, which is responsible for. So before I was talking about Prometheus has to go to predefined targets, or targets where it has to scrap the matrix. So in this case, we have a first component which is retrieval, which scraps the matrix from the target. So we could also say this is one of the important component, right? In Prometheus server, we could also say it like scrap engine, because it performs all its magic to go over here and collects the information about the monitoring. And this target could be like Windows server, Linux server, or maybe Apple devices, or maybe bare metal server. So it is capable enough to get information from all of this. But initially, as I said, Prometheus was designed for the dynamic environment. These are the traditional system, right? You could also use this, but this system doesn't directly support the metrics which are provided by this system, which are not directly understandable by the Prometheus itself. So in that case, we have the exporter. So Prometheus pulls data from exporter or instrumented application via HTTP endpoint. So what is the instrumented application? If you use your application or Prometheus to monitor your application, so you have to instrument some of the code inside that. And who does that? So it is done by the development team. They know what are the application metrics. Okay, so for example, if you remember in part 1 in application monitoring, we talk about the number of requests per second, latencies, right? How your UX or how user behavior or how application is responding when user is interacting with. So there are so many metrics we talk about that. So there are several things we will see that later when we install the Prometheus itself. So, but some of the system or some of the things which are not natively supported by the Prometheus, in that case, exporter comes in. Okay, so exporter, I would say simply for understanding, these are kind of agent, not literally. We will see that in when we install this. For example, your Linux server expose some of the metrics. So exporter translate those metrics into the understandable format of the Prometheus. So this retrieval can pull the data from the exporter. Okay, and in case of your application is there, for example, you have Java application or Go language or Python. So you instrument some of the code. So instrument, it means you put some of the predefined library of the Prometheus, right, with your code. That is called instrumentation. So you are ingesting into that. I will talk about this very detailed because this is really confusing. People really get confused. What is instrumentation? So for example, application is already installed on the server. Okay, so how it differentiate target and the exporter, right? So we will see that in very great detail when we install this. But for time being, understand these are not natively supported or directly supported, or the format of their matrix are not directly understandable by the Prometheus. So we need some mechanism, and that mechanism is exporter. Okay, and now before I was saying retrieval scrap the target, and now I'm saying retrieval pulls data from exporter or instrumented application via HTTP end. So here the difference again. Okay, so let's quickly see first, because it's a kind of a confusion, right? Or I have created kind of confusion. What is exporter? Why I'm using pull data from the exporter and scrap the target? So there is a slight difference. Okay, exporter versus or target versus exporter. So target and exporter are both essential concept in Prometheus, but they serve different role in collecting and exposing metric. Okay, so targets are the endpoint that Prometheus scraps for metrics. For example, Prometheus is configured to scrap metrics from a web server. The endpoint or IP of the server is the target. Okay, or I would say in a way that, for example, you have one server. Let's consider this is one server, and on top of that, this is a Linux server. Okay, and on top of that, you install MySQL. Okay, so this server, which is target. Okay, and as MySQL server is not natively supported by the Prometheus. So what you need some kind of mechanism, and that mechanism is exporter. So you configure and install the exporter on this machine. So this exporter can transform the metrics in Prometheus understandable way. Okay, so this is the difference. So in this case, same server is target, but when you install a exporter, okay, or agent for understanding purpose, so that agent is known or called as an exporter. Okay, and that server itself as a target. So if you see like this, okay, in of course in second and third part we will see how we um, configure this, but just I wanted to show you so you get idea about how it looks like. So in case of exporter, so here MySQL server doesn't natively expose Prometheus metrics. So what we can do, there is an exporter, there is a bunch of lists we will see in next session or next part. Here I'm taking the example of MySQL. So we download and install MySQL exporter on that machine. And here it says scrap config, job name is MySQL. Don't worry about that. It's just a name. We will see how we write, how we put the targets or exporter into Prometheus configuration file in next session. But for now, it says a static config, and here we have targets. So MySQL, and it says 91014. Here what I have done simply, so MySQL server doesn't natively expose Prometheus metrics. So the MySQL exporter details, this one MySQL underscore exporter, it collects all the monitoring metrics and expose it means make them available at HTTP endpoint. So Prometheus scrap that metrics from exported, not directly from the MySQL server, okay, where actually the server is installed. Okay, so instead of contacting directly to MySQL, Prometheus go ahead and contact this exporter. So it says, okay, my translator, do you have anything? It says, yes, I do something for you. So Prometheus says, okay, give me. And that in that way, Prometheus pulls from here. And if the target does natively support Prometheus configurations, for example, like Nginx or CADI or Envy or the HTTP, so many. So let's see the targets in that. So This is where exporter comes in a play, where it is not directly or natively supported by the Prometheus. But when it is applications, for example, I have taken some of the example over here, Nginx KDE or Envoy or something like that. So when you configure Nginx and you enable the module, right? So Nginx natively support. So when you enable that, so automatically all the metrics which is understandable by the Prometheus will be available on this target. So I just put a name, it could be IP, we will configure that. So just for understanding, and this port can be anything. Okay, I just put a random port. Similarly for KDE and all this. So if a system natively support Prometheus, you can configure Prometheus to scrap it directly. So in this case, Prometheus is directly going to this one. And in this case, Prometheus is not going to MySQL, it's going to MySQL exporter. Similarly, when you want to monitor your Linux machines, you install a Linux exporter. When you want to monitor your Windows machine, you install a Windows exporter. So Prometheus is not going to directly pull the matrix from Windows machine. It is asking for the Windows exporter. It's edging. Okay, in this way it works. And this is a summary how it works together. So please pay attention. Keep in mind these are really important and very confusing as well. In your interview, ask sometimes, not sometimes, when especially if you are going into a monitoring, or maybe you're going or taking interview for monitoring role, Prometheus is their primary monitoring tool. Of course, interviewer is going to ask you exporter and target. Okay, so you could say, I just put a simple summary over here: feature, target, exporter. So role, direct source of metrics. Okay, so target is the direct source of metrics. Okay, example is web server exposing metrics like this, and Prometheus scraps the target directly. So here the target directly. Okay, in exporter converts non-Prometheus data into Prometheus format. We already taken this example, right? And Prometheus scrap the exporter, not the original system. So this is the difference about exporter as well as the target. I hope it is clear. Let me know if it is not. I will provide more information regarding. So here what happened, we already saw here we have hard coded this value. So Prometheus know about the exporters and target. So instead of manually defining exporters and target, Prometheus supports also service discovery, okay, allowing it to automatically detect and scrap new instances without manual configuration. So such as the dynamic environment like Kubernetes, container, Docker, AWS, GCP, Azure. So where the workload is very dynamic, this is an assignment for you. Okay, check out what service discovery things are available for AWS, GCP, and Azure. Okay, I thought to put it over here, but go ahead and check it. Okay, if you didn't find it, let me know. I'll provide. So here we know already in our day 7, right? When we learn in part 1 and 2 about the Kubernetes, where pod dies, new pod will come up in self-healing. There are so many things. Similarly with the Docker, right? In AWS, okay, let me give you a hint over here. So you have EC2 instance auto scaling group, where automatically new EC2 instance are getting added when workload increase, right, and back down when workload decrease. So in this kind of, the endpoints are not known. So Prometheus was designed, so it has a specific purpose, but it was not limited to, we could also do this, right? In this case, we have option where service discovery, so where we really don't need to specify or do any of the configuration. Prometheus automatically detect or discover, okay, what are the new servers added, what are the servers are removed from the auto scaling group, what are the new pod has come, what are the new container has come, and so on and so forth. So it is already done by using this. Okay, so for this we have some example. Let's see this. So here, scrap config. Okay, and it is not a static config, it is a scrap config. Job name is Kubernetes node, Kubernetes underscore service discovery config. Here we set a role node, and this is for the AWS EC2 instance. Okay, it's a service discovery configuration in this region. So whatever new instance will come up in this region, it will automatically edit in node. When we install in next part 3, we will also do the walkthrough of where you can see the nodes in the configuration and the targets and all these things we will see in that later. Okay, so everything is over here. And additionally, so instead of manually defining exporters and targets, Prometheus supports service discovery, okay, allowing it automatically detect and scrap new instances without manual configuration. So for that, we already have this one, right? We also have file service discovery as well as HTTP as the service discovery we will see in next our session. Okay, so Prometheus is really amazing, and I'm telling you, this feature I really love because you really don't have to go ahead and configure target or exporter manually. Okay, service discovery helps Prometheus find new services automatically. But what about jobs that run for a short time and disappear? That's where short-lived jobs comes in. Let's understand. So short-lived jobs are like temporary tasks like cron jobs, which are maybe heard in Linux if you use, and Kubernetes cron jobs, batch processing, okay, and ephemeral tasks that run for a fixed duration and then terminate. So whatever work is performing during short amount of time, okay, that comes under short-lived job. So short-lived job push their metrics to push gateway, and there push gateway comes in a play, okay, which temporarily holds the data until Prometheus scrap it. So short-lived jobs, whatever, any kind of job, which is running on the server for a specific duration. Okay, so for that kind of scenario, in Prometheus ecosystem, we have a push gateway. So when the jobs, when they perform or when they're done with their work, they push their metrics to push gateway and Prometheus post those, okay, or scrap those from the push gateway itself. And it should be only used for in this kind of scenario. Okay, it should not be primarily being used. Okay, because that is not the Prometheus is meant for. Now we have collected data, okay, from various sources. So we have collected data from exporter, target, push gateway, service discovery, web servers, right? Short-lived jobs. Now it needs to be stored efficiently for quick access, and so we need something kind of course we have data, so we need some kind of database for the same. Okay, that's where time series database, TSDB, okay, play a key role. Okay, Prometheus uses time series database to store timestamp data, making it easier to query, analyze, and set up the alerts. So when Prometheus pulls or scrap, or however you would like to say, okay, data from all this, okay, all these places, then it has to store somewhere, and it is stored in the form of time series database. Okay, so again, the thing is, what is time series data? So time series data is simply data points collected over time, okay, where each measurement has a timestamp. For example, when someone has a fitness tracker, okay, that records heart rate, okay, every minute while that someone is exercising. So each time the tracker saves the heart rate, okay, and it also notes the exact time that measurement was taken. Okay, over the time it build up as a set of data that looks like this. Okay, so let's say 8 o'clock heartbeat was 80, okay, and after 1 minute tracker again tracks 85, 90, 92, and also while it was observing, okay, or the tracker recorded the heart rate, it also put the exact or recorded exact time. So that's how it is called time series data. So now Prometheus does the same thing for CPU memory consumption or even number of web requests for your application. It constantly collects new measurement at regular interval, building a historic record. Okay. So similarly, Prometheus also does the same. In this case, I have just taken an example of simple CPU uses, okay, from this Nginx, caddy server, and Envoy proxy. Okay, so we saw these are the value. So we could see, okay, CPU uses on this date and this time. Okay, so every 1 minute it is getting recorded, or Prometheus is storing this or pulling the matrix and storing in the time series data. So it time series data is looks like this. So it has time as well as the value. Okay, it also has metric name instance. We will see that in very good details, so don't worry about that, but just wanted to let you know how, so you can understand what time series data it means. Okay, so don't be afraid, it's very simple. We are collecting information and we are also recording the time. So these are already predefined. We know, okay, from where we have to or what we want to monitor and which thing we want to monitor, and on that thing what we want to monitor specifically. So we want to monitor CPU uses on Nginx server. Okay, so these two things are already known. So Prometheus does its magic, pulls and store. So this was the percentage of the CPU utilization, and if we are interested when, so this is the date and this is the time. Okay, similarly for this as well, for this as well. So these are just some of them. We will see how we can see the metrics. Okay, so let's switch back to the architecture diagram. So now we understand we collected data from all the sources and put it in our time series database. So this is another teammate of the Prometheus server. And now we have the data. Prometheus checked based on the configure rule, it find something is not happening good. So Prometheus a push alert and push alert to alert manager. And then alert manager, we know alert manager is responsible for sending email or chat or whatever communication channel supported or you configured for. Okay, so it sends a alert over there, and after that team notified, that we already talked what is alerting and notification in part one, but it's a simple procedure. So in this ecosystem, so far we have collected data, so I mean data from all these sources, and it is done by the retrieval, okay, or scrap engine, and it is stored in the database, time series database, in this format. And if something goes wrong, it sends the alert and all this thing. But Prometheus is not only sends alert, it also has HTTP server, which is kind of API which help us to see the data. Okay, we also want to see the data sometimes for the analysis purpose, or maybe application performance optimization, or maybe fine tuning of the resources. There are several purposes for that we want to see the data, and for that Prometheus also comes in with the inbuilt web UI whenever you want to access data, okay, via the web UI. But sometimes, I mean, not everybody is very familiar with the web UI, which is pretty simple or very basic to run your queries from there. So to visualize the stored data, right? So where we use the Grafana itself, and all these things happen by the PromQL. So in that case, whenever we access any UI, we run the any of the query, it reach to the HTTP server, and HTTP server pulls the data from over here and provide the visualization over here. But for the best visualization, yes, Grafana is the uh, recommended tool, which is also officially documented and mentioned in Prometheus official documentation as well. Okay, so these are the way by which we can visualize the data. Okay, so this is of the architecture. Here we have saw. So basically, we have this is the heart. Okay, Prometheus server. It has three components: retrieval, which can be called as a scrap engine, which is responsible for collecting data, monitoring data from the exporter targets, okay, from the service discovery, automatically discovered targets as well, and from the shortlist where push gateway comes in. So it collects data from all these resources. When it collected all the data, after that it is stored in database, and this database is time series database. And if something need to alert, so alert manager comes to the play and take the necessary action, inform the team based on the whatever configuration channel are configured. Okay, and then if you want to retrieve the data or run any of the query using web UI, then we have to access HTTP server, or we communicate with the database via the HTTP server, which provides the endpoint, HTTP endpoint. And for monitoring, yes, of course, Grafana is one of the best tool I found in my overall experience. This is about the monitoring. And as I promised, we will refer back the definition again. So let's refer that and understand. Again, Prometheus is an open source monitoring system, time series database. I explained you what time series means. So database is simply to store a data, but catch here is the time series. And time series, it means we are recording the value as well as the time, collecting and storing. So metrics is already mentioned. So for timing, let's say the matrix is just a CPU uses, memory uses, and in terms of your application, how it is behaving, okay, how it's a latency. So many we when we install, I will practically show you what is this, and here the pull based model. So now you understand what is pull based means, right? It is not pushed based. So for example, Prometheus is monitoring 1000 server, and at the same time 1000 server sends the data to the Prometheus. Then what happened? Server might crash. I just give it example. But when data is unhandleable, right, in that case server could be crashed. Instead of post bash, it works based on the pull bash, right? So similarly, like whenever you get time, you watch the playlist, okay, and whatever video you want to, or whatever tool you want to learn, you just pull the video and learn that technology instead of somebody is asking you to do that, right? So similarly, now we also understand what is scrap. Scrap means that is simple collecting a data. So it's a process, right? Matrix, of course, and predefined target. So now we understand target, and as I mentioned, some other terminology, exporter and regular interval. So regular interval, 15 seconds, 10 seconds, 1 minute, depending on what critical or how critical the application is. So all these things which I mentioned is completely based on this thing, based on the experience. So in your interview, of course, you feel free. I'm not saying the official document, the definitions are bad. Of course, those are really, really good. But if I were you, I will explain Prometheus like this and increase my chances of getting hired by providing this feature. So I hope this is informative session for you. And now let's go ahead and see the conclusion and what next is coming up. So before we wrap up, if you have any questions or any suggestion, any thought, or you would like to suggest any of the topic, feel free to drop them in comment section. And I'm sure this session was informative for you. If this is the case, please leave a thumbs up to this. And if you are new to our channel and would like to support us, please subscribe to our channel. And in next part 3, we are going to install Prometheus as well as Grafana on Linux server and see in great details how and where we configure. So whatever we have discussed in this ecosystem, right, different components, when we install, we will see everything in action doing the hands-on. Okay, we will also see how we can see the metrics, how where we see the metrics, where we see the nodes, how this alert manager works, how this push gateway works, right, how we configure the target, how we configure the exporter. Everything we will see in part 3, and which is completely hands-on. Okay, so stay tuned. And thank you very much for your kind support and love. Thanks very much for that. So see you next week with more details. Until then, bye bye.